Great. 10.5 is a relatively short lesson. I hope I don't make too many mistakes writing it down, and then this won't take us way too long to do this. First thing I want to say is just that as you're going through 10.5, you're going to need some formulas, and sometimes I pull those out of my head, or I may write them down differently, but if you need to find formulas, you can, in Blackboard for this course, go into Lessons, go into TI 83, 84, and MML Resources, and down at the bottom there's a formula card. So I will try to show you how to get to that first. Just right here, if you go to Lessons, here's your resources, and then down at the bottom here there's a formulas card, and if you open that, I've already downloaded that and opened it. This is what it looks like, so that you've got a Word document, and so you can find the shape you're dealing with, and it's got formulas for those, the volume and the surface area. And then it's also got this one other formula we're going to end up using today. So let's go through some of these examples, and this is not an incredibly long lesson because really it's an application of formulas. So we just have different shapes along the way, okay? I think it shows up well. So if I'm going to find the volume of this one, volume of a box is like the length times the width times the height. So I've got 2 times 2 times 5, and 2 times 2 is 4, 4 times 5 is 20, so this one is 20, and it's meters cubed, because anytime you're doing volume, you're going to have the units cubed. So look for those 3's, okay? Now this capital H says 10 feet, but do know that's not written on the side. Actually, that should represent a perpendicular height that is going down here to the middle of that. But the volume of a rectangular pyramid is 1/3 the area of its base times its height. But its base is a rectangle, so it's length times width. So that means we've got the volume is 1/3 the length times the width times the height. So when you see capital B, it normally is the area of the base, the area of the flat surface it's on. So here we have 1/3 times 5 times 6 times 10. The order that you multiply this doesn't really matter, so 5 times 6 is 30. 30 times 10 is 300, and 1/3 of 300 is 100. It's all measured in feet, so I have cubic feet. The volume of a cylinder is the area of the base times the height, but the base is a circle, so that's going to be pi r squared. So it's actually pi r squared times the height. Now it says give the answer in terms of pi, so just remember when you need to do that, simply multiply the other parts of the problem and then write pi with your answer. So I have pi times 9 squared times 10. 9 squared is 81. 81 times 10 is 810. So this is 810 pi. And then it's inches cubed. That's the first part of my answer. Then round to the nearest whole number. So I'm just picking up my calculator and going to punch in 810 pi using the pi key. I get 2544.69. You know, that decimal just keeps going, but I just want to look at the first spot after the decimal because I have to round it to a whole number. So 2544.6 rounds then to approximately, so we use a wavy equals for approximately, 2545, and then that is inches cubed. So we have both of our answers there. The cone, first of all, this is showing a diameter, but if that's the diameter, then the radius is half of that, so the radius is 12 inches. Now, volume of a cone is 1/3 the area of the base times the height. Again, the base is a circle. So we have pi r squared. So we have 1/3 times pi r squared h, which is 1/3 times pi. The radius is 12 squared, and the height is 9. So let me multiply that out. That comes out to 432 pi. So I'll just write that right here. And that's inches cubed. Now I need to get the approximation to the nearest whole number, so 432 times pi is 1357.1 blah, 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 blah. Put 1357.1 rounds off to the nearest whole number to just 1357. So applying the formulas. So same kind of instructions here. This one's a sphere. On the sphere then, once again, we have, that's the diameter. So that means the radius must be 6 feet. Okay. The formula for the volume of a sphere, and this is on that formula card. Again, I'll just show that one to you real quick. It's right here, 4/3 pi r cubed. R is the 6. We're going to have to cube that. That comes out to 288 pi. This is measured in feet, so we have feet cubed. And then the approximation, which I'll just write out here beside it, 288 pi, is approximately 905. It's 904.7 blah, blah, blah. Okay, now for this next one, what you just want to do is take it apart. You have a pyramid and then you have a cylinder. I mean, not a pyramid, but you have a cone. So for the cone and then the cylinder. And then we're just going to add those together. The cone, which we did on the previous page, is 1/3 pi r squared h. And the cylinder is pi r squared h. Now these two h's are not the same, but they are the height of those part that it's with. So this one is the height of the cone, and this is the height of the cylinder. Now the height of the cone then is not labeled, but it would go right here where I'm putting that little extra line. And if you look at that then, if I finish that out, and this is where we know that things are definitely not drawn to scale, that would just have to be the other 2 inches. It certainly doesn't look right, but if this entire thing is 10 and the cylinder is 8, the cone has to be 2. So I have 1/3 pi, the radius is 9, because again, if this down here at the bottom, that's the diameter. So the diameter is twice as big as the radius, so the radius would have to be 9 inches. And then the height of the cone is 2. So I'm going to leave it in terms of pi first of all. So this one comes out to 54 pi. Now let's look at the cylinder. The cylinder is pi times, it's also got the 9 squared. The height of the cylinder is 8, 648 pi. Now again, what we've got is our 2 answers here that we need to combine to get that full shape. So 54 pi plus 648 pi, just leave pi, And that gives me 702 pi. These things are all measured in inches here, so now I'm ready to put my units on it. So that's cubic inches. And now, for my approximation, 702 times pi. 2205, approximately. Okay, so when you've got shapes, you may have to take them apart and kind of do those in pieces and then put them together. Okay, I think we've done we haven't done lots and lots of problems, I get that, but we've done a sample of multiple types of volume. Going back through then, just right here, we have a rectangular box or a rectangular solid. We have a pyramid, a cylinder, a cone, a sphere, and then we have a composite is what we call it when we have more than one together. So this one is a composite shape. So shifting over into surface area. Surface area is not about how much something holds. It's really about the minimum it would take to cover it. If you wrapped presents at Christmas and you didn't let the paper overlap at all, but yet you covered the entire box, exactly what would it take? Let's see where I can draw on here. This box, if I wanted to talk about this box, it has a top and a bottom. It has a front. And then it kind of has a left back. And it has a right back. So what you want to do if you're finding surface area is find the surface area of each one of these. And let's add them all together. So if we take the top and the bottom, add the front, add the left back, and add the right back. Now you might not need this, but not everybody's as visual as everybody else. And of course, if you're visual, you were probably wishing I could draw this really well. But the top and the bottom are the triangular shapes. And one of those dimensions is a 3, and the other one's a 4. Everything's measured in centimeters. The front is a rectangle. This is a 9. We're going to need to know what that other piece is, but it doesn't tell me right off. The left back is the one I'm looking at over here that has the 3. And it really is a rectangle too. It's just that we're kind of looking at this slant. And the right back has a 4. It's also a rectangle, but it's just kind of slanted. So those are the pieces if I took them all apart. Now, this left back and the right back still both have a height of 9, so I can go ahead and label that. So it's really only this other dimension on the front. I'm going to have to stop and calculate. In other words, I need to know what is this piece. So before I get into the actual surface area, I'm just going to kind of go off to the side here, and I'm going to calculate the length of that piece. It is a right triangle where the pieces that meet in the corner measure 3 and 4. That means I can use the Pythagorean theorem for right triangles on your formula sheet. It is right here. And C is the side that I'm essentially needing to find because I know the two pieces that make the right angle, so I need to find the other one. So A squared plus B squared equals C squared. I'm going to go over here then and say that 3 squared plus 4 squared really equals, and I'll just put a little question mark there, a question mark squared. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So 25 is equal to the side that I need to know squared, which means I can take the square root of that, kind of work it backwards, and my side length must be 5. Now that I know that's a 5, I'm going to go over here to the front, and I'm going to label the top of that a 5. Okay, so how do you find the area of a triangle? It's 1/2 of its base times its height. But let's just pause for a minute. I have 2 of those shapes. All the other ones I just have 1 of, but I have 2 of those. So I'm going to have 2 of that. Now that 2 kind of undoes the half, and I'm left with 12, putting the top and bottom together. Now, on the rectangles, it's much faster. 5 times 9, 45. 3 times 9, 27. 4 times 9, 36. So I'm going to add all of those pieces and then put my units with it. So 12 plus 45 plus 27 plus 36, and that's 120. So this comes out to 120. Now for my units, it was measured in centimeters. This is area, so it's centimeters squared. That's your answer. Our next one, thankfully, has a nice little formula. If it's a nice rectangular box, if you look here, the surface area, if you have a length, width, and height, it's 2 length times width, 2 width times height, and 2 length times height. So if I go back over here and call this length, width, and height, that formula was the surface area is 2 length times width plus 2 width times height plus 2 length times height. Just filling in the numbers now. Doing the math, 2 times 5 is 10, times 12, 120. This one is 192. 2 times 5 is 10, times 8 is 80. 120 plus 80 is 200, plus 192 is 392. Yay for the rectangular box. It was a lot faster, wasn't it? It is squared because it's surface area. Okay, guys, we just got an application problem or 2 left, I think. So, if we have a circular backyard pool, then when you're looking at it, because it has a depth, and we're looking at kind of an above-ground pool then, it's going to look like a cylinder, really. So I know this won't draw well, but we have a pool here. The height of it is 4 feet. The diameter is 20 feet. Of course, if the diameter is 20 feet, then that means the radius is 10 feet. Now, a cubic foot of water has approximately 7.48 gallons. I'm just going to write that down here a little bit. 1 foot cubed goes with 7.48 gallons of water. Water costs $2 per 1,000 gallons. Okay, we'll kind of write that down. We have $2 per 1,000 gallons. How much will it cost to fill up the pool? Well, if we have to fill the pool, then we need the volume of the pool. So we're going to go over here and find the volume. The volume of the shape is pi r squared h, which is pi times 10 squared times 4. That's 400 pi. And then it's all measured in feet, so that's feet cubed. Okay, now since it's saying to the nearest dollar and I want to approximate, I could go ahead and multiply that pi in and then just kind of round it off. So 400 pi gives me approximately 1257. And again, you don't want to round unless you know your problem is telling you to. This one's not quite as direct, but it says to the nearest dollar. I am going to have to round. And I don't have to be extremely precise yet because it's $2 per 1,000 gallons. Okay? So I just kind of have to be close to the nearest 500 gallons. Okay, so now I'm going to use this conversion factor. If 1,257 feet cubed is what I have, and I know that 1 cubic foot is 7.48 gallons, I'm just going to use a basic ratio here to solve for this. Really, you can solve for ratios by doing cross products. And I thought I would have a highlighter there, but I'm just wanting to multiply. So I need to take 1257 times 7.48. I guess use parentheses so that my decimals don't look the same. And that's going to be my cross product, and that will equal 1 times x. So 1257 times 7.48, and that comes out to approximately, and it's not exact because again I am rounding, that comes out to 9,402 gallons. Okay, now I have 9,402 gallons, and I need to pay approximately $2 for every 1,000 gallons. So I can set up another ratio and say, well, how much do I need to pay for 9,402 gallons if it's $2 for every 1,000 gallons? So again, I'm using cross products. 9,402 will be multiplied by 2. 1,000 times x is 1,000x. So 1,000x comes out to 18,804. Divide both sides by 1,000. And x is equal to 18.80. And the reason I cut it off at 2 decimal places is because we're talking about money. However, that still wouldn't be the answer. If I put that in online, it'd be wrong because it didn't say to the nearest penny. It says to the nearest dollar. So to the nearest dollar, well, $18.80 is closest then to $19. And you know what I think? I think in July, having that pool is going to be well worth $19. Fill it up. Bye-bye.